Okay, so we have discussed like end-to-end flow of this MapReduce, and this diagram actually, will help you to create overall, image of MapReduce end-to-end. Because the thing is, since it is distributed, it is very difficult sometimes to imagine, again, until unless you don't do much practice on it. Okay, but this particular diagram, it's very handy. I mean, you should keep it handy in order to just whenever you see anything, just try to just try to visualize this, and you will easily understand that how the things are going. Okay, so if you see uh, this custom partitioner, right, that we were discussing about, it actually routes A and B to reducer 1, C and D to reducer 2, and E and F to reducer 3. Depending on how many number of reducers you decide, the custom partitioner will behave accordingly. Okay, the number of reducers should not be more than the number of unique keys in your data. So suppose we already know that we do have only A, B, C, D, E, F. So only 6 unique keys are there, right? So if you put 10 reducer, you can put, but the thing is only 6 reducers will get some data, but 4 reducers will be blank, or 4 reducers output will be blank. Okay, now few considerations that we need to discuss over here is like, suppose this map task 1, right? So map task 1 can start on any data node. I will say dn1 over here, then with this is dn2, data node 2, then this is 3, and this is data node 4. Okay, now if you see, there is one term called data localization. Okay, basically this is MapReduce framework. Okay, so MapReduce framework will guarantee you that whenever you get the output, okay, so just leave that. What I'm trying to tell is basically this block 1, block 2, block 3, block 4. Okay, each 3 copies of each block is going to be present on 3 different data nodes. So let's say block 1 may present on data node 1, 2, 3, block 2 is present on data node 2, 3, 4, block 3 is present on 4, 5, 6, and block 4 is present on 6, 7, 8, whatever. Okay, so when MapReduce frameworks comes at a point where it needs to submit the map task in order to process the, let's say, block 1. So if we pick the block 1, and let's say block 1 is present on data node 1, data node 2, and data node 3. This is the 3 data nodes where this block 1 exists. Okay, so MapReduce framework will try to choose any of this data node in order to submit this map task. Why? Because it always try to submit the map task on that particular node where the data is physically hosted, so that map task can easily read the data in faster way. Okay, suppose the blocks are present on 1, 2, 3, but let's say the map task that is going to process this block is going to be submitted on 5. Then what will happen? This is also a normal case. Basically it could happen, but then MapReduce is trying to avoid it. Okay, why? Because since the data is not physically hosted on data node 5, it needs to start copying the data for that block from either 1 or 2 or 3 to data node 5. Okay, and then only your map task will be submitted over there, and then only your map task will start there on data node 5 and start processing block 1. Okay, so inherently MapReduce is designed in such a way that it is trying to find the data localization. It means that where the block is physically hosted, only that particular on that particular node only the map task is going to be submitted for processing that block. Okay, and this will be done in case of only map phase. Why? Because map is actually the program or the piece of code, or that task itself will read the data from block and then generate intermediate result. Because once map task generates result as an output, as an intermediate result, basically it again needs to be diverted to their respective reducer node, and for running reducer there is no data localization concept used. So data localization is a concept where the MapReduce inherently try to find or try to submit the map task on only that node where the block is physically hosted, so that the reading, so the speed of reading would be faster, or because since it is physically hosted there, it can easily read the data and then start processing it. Okay, that is what is called the concept of data localization. So data localization will be followed only in map phase, okay, but not on reduce phase, because in reduce phase there is again no guarantee, I mean, which data will go where. Okay, so there is no, so reduce phase can start anywhere. So while starting the reduce phase or while submitting the reduce tasks, the MapReduce framework will then think that which node is more free. Okay, so it's like completely, completely about the resource management. Okay, how the resources will be managed. So resources will be managed on the cluster level. You will have a lot of CPU cores, you will have a lot of RAM, lot of hard disk. Okay, and then depending on that, basically you will depending on it, the MapReduce framework will decide that okay, this is where we can go for. Okay, now there are schedulers. Okay, whatever is going like where the map task will be submitted, where the reduce task will be submitted, how many number of map tasks, how many number of reduce tasks, everything, and the allotment of resources to this task. Allotment of resources means this, since this is a map task, it is a JVM, it requires resources, right? It requires number of cores of CPU 2, 3, 4, whatever being designed, whatever being configured for it, then the RAM, whatever is configured for it. So it needs to acquire all the resources needed for this particular map task to run or reduce task to run. Okay, so all this resource management is actually done by a completely separate framework called Yarn, or completely separate resource manager itself, that is what is called Yarn. Okay, so in Ambari basically we will use Yarn, YARN. Its full form is yet another resource negotiator. Okay, so in the next class what we will do is basically, since whatever basics we have gone through, we will then understand the programs for map task and reduce task in Java. Okay, we will go through the code, we will take a sample data, we will run the MapReduce part on it, we will play with it. We will play with this custom partitioner, make it more, instead of using default partitioner, we will use custom partitioner, and we will try to play with the keys to be gone to only one reducer or whatever reducer we want. Okay. Then there is something called combiner. So if you see that we are actually combining the results over here on the last part over here, right? This is 1 1 1 1 1 1 1 over here. So there is a combiner function that will make your overall MapReduce much faster. How come? It's very simple, and it can easily be understood from this figure itself or this picture itself. So what I do is, on the reducer side, the final logic would be I should go and iterate over this list of values and then combine all this one to form a single number. So 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus. So this will all finally will be combined to the number 12, right? So these list of values, this list of values is the summation would be 12. Okay, so we first allow it to brought to the final reducer end, and then we are actually doing the final calculation. But instead of that, if we could start calculating, because we know that this in this logic we can just sum the numbers for their respective character, like a, how many times it appears. So we just keep it summing, and then finally we do further sum in order to get a final count. So instead of sending this a and 3 times 1, we could send a comma 3. Okay, so here in this particular part over here, we are actually talking about the network transfer. Okay, here the network involved. So this is network that comes in between, because this could be data node 1, this could be data node 2, this could be data node 3, this could be data node 4. Then here we have data node 5, 6 and 7. So between 1, 2, 3, 4 and 5, 6, 7 we are having the network transfer. I mean, we do have the network, and then this is like the transmission of data from one place to other place. Okay, so here the heavily network involved. So suppose if you really want, so 1 is again 1 byte and 3 is also 1 byte itself, right? So if you talk about this 3, it is only single byte, and this 3 ones is, it means that 3 separate bytes. So we can easily reduce the number of bytes getting transferred from 1, 2, 3, 4 to 5, 6, 7. Are you getting me? So that is what is called combiner function. So there is one more program that you can write and pass it on to the MapReduce framework, and that combiner will be, is in some specific time, some number of frequent, some number of times it will get evoked and try to combine the result there itself before it is getting transferred to the final reducer. Okay, so what it will do is, instead of transmitting 3 times 1, it will only transfer 3. So we are actually saving the number of bytes getting transferred, and hence we will speed up our transfer speed. Are you getting me? So instead of transfer 3 times 1, we are actually transferring 3. So here you will get at the final merge is a comma, and then from the first mapper it is 3, second mapper it is also 3, from third mapper it is also 3, and for fourth mapper it is also 3, and then finally you just need to again sum them up to a final number that will again come to 12. Are you getting me? So this is how the combiner function will work, and then it will reduce the number of bytes getting transferred from the map output to the reducer input. Okay, so combiner function, custom partitioner, okay, that which key should go where, that also we will decide if we want. Okay, then we have seen the data localization concept. What is it? Basically, data localization is means the map task is going to start only where its corresponding block is present physically, and for reducer there is no concept for localization, and reducer will start where the resources are more free. And all this resource management, it means like what are all the resources being given to this tasks are being done by yarn, yet another resource. So we will understand the yarn architecture later on when we go through the MapReduce programming. Okay, so this is conceptual. Okay, as of now I just try to introduce the concepts of MapReduce, why it is so famous, because it can work on the distributed data and still give you the final result. Okay, that is what is the beauty of it. Any questions?